Okay, so the next question is a Hess law problem 2, where we are given N2O plus NO2 giving NO 3NO, and we are supposed to figure out the delta H associated with that. And for that, hopefully you can see when I compare the three reactions, let's call them 1, 2, and 3. I have no N2, I have no oxygen in the final equation. That means these must get cancelled somehow, and you can hopefully see that there are 2 nitrogens in equation 3, only 1 in equation 2, so you must multiply equation 2 by 2, and then you probably should be adding that to equation 3. Let's do that first. So it'll be 2N2 plus 2 oxygen plus 2N2O is equal to 4NO plus 2N2 and an oxygen. The delta H will look like 182.6 times 2 minus 163.2, and so the nitrogen is going to cancel off, one of the oxygens will cancel off. My equation starts looking like oxygen plus 2N2O gives you 4NO, and delta H associated with this should come out to be the 12, 1, 4, and 5, 2, 6, 16, minus 1, 62, 202. 202 kilojoules is the heat that I'm getting as of right now. 202 kilojoules. So that's the first thing. Now I am supposed to retain an O, I am supposed to retain N2O, but I am supposed to get rid of the oxygen. So how can I do that? Notice my NO2 is supposed to be on the left hand side in the final equation. So what if I flip equation 1? So 1 times -1, and I'm going to add that to 4. So what that is going to look like is 4, not 4, I didn't multiply that by 2, so 2, not 4, 2 NO2 plus O2 plus 2N2O gives you 4NO plus 2NO plus O2. Oxygen and oxygen will cancel off. These two can be consolidated to be 6NO. And since 2 is a common factor, you can simply, let's first calculate the delta H and then we'll divide that by 2. So the delta H is going to come out to be, so remember we had flipped that with negative, flipped the equation, so multiply that by -1, and we had added that, so 202 plus 113.1 is going to be 0.151315.1 kilojoules. And now since all of it is divisible by 2, I'm going to divide that by 2, and so I must do the same thing for the heat part as well. So that should come out to be 157.55 kilojoules as your final answer. And likewise, I have another problem which is also a Hess law question. We are given 3H2 plus ozone giving you 3H2O. Delta H associated with it is what we are trying to calculate, and we have 2 equations that are given. One is 2H2 plus oxygen giving you 2 water molecules. The delta H is provided, and likewise we have another one, 3 molecules of oxygen giving you 2 molecules of ozone. Delta H is provided for that as well. Notice that in my final reaction I do not have any oxygen, so we must get rid of that, and in order to do so we probably should multiply equation 1 by 3, and we should probably flip equation 2, so that means we should multiply that by -1 and simply add those. So that should look like 6H2 plus 3 O2 gives you 6 H2O, and delta H for that is going to be negative 483.6 times 3. And we are going to also flip the reaction. So this is going to be 2O3 and 3O2, and we are simply going to add the 285.4 after we have flipped it. And from here you can hopefully see that the 3O2 and 3O2 is going to get cancelled off, and you'll get the final equation, but we will need to divide that by 2 because all the three coefficients are divisible by 2. So here you're going to get comes out to be negative 1736.2, but that is for the 2 moles of ozone. So we are going to divide this by 2, and the final answer comes out to be 3H2 plus O3, giving you 3 molecules of water, and you must divide the delta H by 2 as well. So negative 1736.2 by 2 comes out to be negative 8.1 kilojoules as your final answer. Next, I have this reaction. 4 ammonia plus 5 oxygen gives you 4 NO plus 6 water, and the standard enthalpies of formation are provided to you. Realize for an element it's going to be 0, so even if that number is not given to you in a test, you should know that for a pure element that number will be 0. But for this reaction, you can say the delta H reaction is going to be equal to all the products put together times their number of moles of the products, and from that you're going to subtract all the reactants times their number of moles. So my products are NO and H2O. So all I'm going to do is I'm going to consolidate the data, and I would say that 4 moles of NO are being formed. So I'm going to multiply that number by the number that is given for NO. Realize each of these numbers will be a per mole value, and since we are multiplying that by the number of moles, the mole and mole will cancel off, and your final unit is going to be that's going to be just kilojoules. We have 6 moles of water, and each gives us negative 241.8 kilojoules. And from that we are going to subtract 4 ammonia. Each ammonia is at negative 45.9. And we have 5 oxygens, each at a 0. So that factor would be 0 really. And when you work this out, that comes out to be negative 902 kilojoules. And that will be your answer. There is another one that says here 2 aluminum plus Fe2O3 gives you Al2O3 plus 2 Fe. It's important to realize that you always begin with a balanced equation, and now again consolidate the products together. So you have the delta H reaction as negative 1675.7. You're getting only 1 mole for that. Iron in the elemental form will be 0, and so will be aluminum. So 2 times 0, we are not going to count that. And for Fe2O3, the number is negative 824.2, and of course aluminum will be 0. So you really are basically subtracting the heat of formation for Fe2O3 from Al2O3, and so the number comes out to be negative 851.5 kilojoules, and that is going to be your final answer. The last question is a city of 100,000 people approximately uses 1 times 10 to the power of 11 kilojoules per day. Suppose all of that energy comes from combustion of a liquid, octane, which is C8H18, to form gaseous water and CO2. Using the standard enthalpies of formation, calculate delta H reaction is again what we are seeking. Delta H reaction for this combustion reaction. And you also have to determine how many kilograms of octane would be necessary for providing this amount of energy. So a couple things here. If it's octane, which is C8H18, if you write down the balanced equation to get CO2 and H2O, realize you have 8 of the carbons. That means you need to multiply CO2 by 8, and you should multiply H2O by 9 so that it reflects 18, and that gives me 16 plus 9 is 25, so 25 by 2 of the oxygens. This is my balanced chemical reaction. And you know that for CO2, the heat of formation is negative 393.5. For water, it's negative 241.8. And they said that those are my gaseous products, so that's what I'm going to stick by. Oxygen, the value will be 0, and octane has a value of negative 250.1. Of course, you're not supposed to know these numbers. I mean, if it's a right now, since it's a worksheet, you have the time of the world to look through the book, see through the book. But of course, if it's a test question, then those numbers will be provided to you. So if I now use the same method that I have been utilizing, that you consolidate all the products together, and from that you subtract all the reactants, what we are doing is we are multiplying the number of moles of each of the products and each of the reactants, and then just simply going products minus reactants. So you have 8 times negative 393.5 kilojoules plus 9 times negative 241.8 kilojoules. From that, you're going to subtract off 1 times negative 250.1 kilojoules, and of course the oxygen is going to have a 0 component, so you can multiply that by 25 by 2 if you'd like, but that is not going to count. When you actually work this out, it comes out to be negative 5074.1 kilojoules. That's what I'm getting on my calculator. Now we are given that the city uses up 1 times 10 to the power of 11 kilojoules of energy. That is what the city essentially utilizes. And realize that since this reaction, this combustion reaction, this must emit out that much energy, we are going to use that as a negative sign, just saying that this is an exothermic reaction. We also know that this value of the 74.1 kilojoules is true for 1 mole of octane, C8H18. So the kilojoules and kilojoules will cancel off, and you know that a mole of octane is going to weigh 114.2 grams, and we also know that 1,000 grams, because ultimately the answer is supposed to be in kilograms, is a kilogram of, so gram and gram will cancel, mole and mole will cancel. When you solve this, the negative and negative will cancel. When you solve this, the answer comes out to be 2.3 times 10 to the power of 6 kilograms octane, C8H18. So we will require 2.3 times 10 to the power of 6 kilograms of octane every day to be able to run this, the energy demands of this city.